Welcome everyone to this speaker session hosted by Google Developer Student Club at Technical University of Munich. And before I introduce today's speaker, I want to do a brief introduction about us and about this community. So first, who are we? We are all students based in Munich, and we are passionate about building and growing this developer student club. And if you have ever the chance to join our past events, you might already be familiar with Florian, Viviana, Andreas, and Bezan. They founded DSC Munich in 2019, and Melanie and Daniel joined us last year. And now this year, we have 2 new members, including myself. So my name is Liangda Wang. I just started my master's degree of information system at TU Munich this semester. And currently, I'm also a software development engineer working student at AWS. I'm passionate about cloud computing, web development, and machine learning. In this and the next semesters, I'm going to be the DSC Munich lead, and I'm super excited about this challenge. And also we have Adrian Meter, who joined us recently, and he's going to moderate our Q&A session today. So Adrian, feel free to introduce a little bit about yourself.
Hi everyone, I'm Adrian, and I'm in my 3rd semester of informatics at TUM. And I recently joined GDSC, as Liangda mentioned, so I'm looking forward to have some cool events with you. And yeah, technology-wise, I'm mostly interested in backend development, cloud computing, and also blockchain. So if you're interested in it, just let me know. Feel free to reach out to me. And yeah, I'm looking forward to the events with you.
Great, thank you. And now let's zoom into what exactly the Developer Student Club is. We are a university-based community group for students from all programs who want to grow as a developer and gain more practical experience. To do this, we will organize workshops and invite experts to tech talks. We will do projects together, and we do all of this in a peer-to-peer learning environment. So please make sure to join the community to receive our newsletter and get updates about our exciting events. And now I don't want to waste any time. Today we are honored to have Dr. Xiao, the CEO and founder of Gina AI, with us to speak about the future development of AI. So Dr. Xiao, thanks for coming, and the stage is yours. I will stop sharing and you can start.
All right. Okay, so I'm going to share my screen. All right. Can everybody see my screen?
Yes.
All right. So hello, everybody. So I'm very glad to present this talk here, and I think I'm also from Munich, like a couple of years ago. I studied in TU Munich in 2009 for my master, and then got my PhD in 2014. So then I moved to Berlin, and I joined Zalando working as a research scientist. And then later I moved back to China, and then now I come back to Berlin and then set up my company here. So I will show my story later, because this is quite an interesting and long story, which basically kind of like feeds the change of deep learning and all this kind of evolution of deep learning. Right? So today I want to talk about this title is a little bit clickbait, right? So the first step to AI first is a little bit clickbait. But I want to talk about my insights, like my experience when go over all these years doing AI. I start doing AI from 2009 when I was writing my bachelor thesis. I was doing some Bayesian model, right? So like a parametric Bayesian model. I don't know how many of you know this thing. Is very old. Back in the days, I was studying a model called latent Dirichlet allocation. Basically, nowadays people call it topic model, but it's a Gunners, right? So it's not really used anymore, right? People talk about GPT, talk about BERT, but back in the days when people talk about natural language processing, back in 2009, so this LDA was kind of like a very popular thing, right? But nowadays people don't use it. So over the last 10 years, right, I was go over all my history, like the experience when working at the university as a research scientist, as a WIMI, right, so wissenschaftlicher Mitarbeiter, back in Munich, working in the research domain, and then later move out from university, working in the company, in the a commercial company like Zalando, a very consumer-driven company like Zalando, and then work in the Zalando research team, and then later move back to China, work in Tencent, one of the biggest internet companies in the world, work in the AI lab of Tencent, and then now building my own AI company. So what is the lessons learned from my side? This is the topic that I want to share with you today, right? And yeah, the first step of AI first, is forget about AI. Right? So I will talk about this later. The why I'm like you see, why I'm here to talk about this, because I'm currently running AI startup in Germany, and we founded the company is founded in February last year and during pandemic, and right now we have more than 35 people all over the world. Our headquarters is in Berlin. We have 2 offices, one in Beijing, one in Shenzhen. In China, we have 10 people. And then for the rest of the team, we have people in India, in Spain, and North America. We're backed by a very top investor. So, and we have right now, we are, in terms of the fundraising, we are right now closing our Series A, and we have very good news on the Series A. So I'm very proud to say that, if you look at overall from Germany or from Europe, we are one of the best AI companies, not only in Europe, but let's say in the world. Right? So, and I mean, for example, in the last year, in early this year, we are listed in CB Insights AI 100. All right. So this is the list that includes all the AI companies, not only startup. Right? So let's say you may find some very familiar faces like a Hugging Face, Rasa there, and we were listed with them. Right. One of the top AI companies in the world. And we are also, of course, listed under Forbes DACH region, this top AI 30 companies. Right, so that's kind of giving me the confidence of having this talk, right? Otherwise, you probably think, oh, who is this guy? Like, come from nobody, right? So I just briefly introduce my experience before, right? So I did my master and PhD in Munich, and then later moved to Berlin, and then doing some research engineering, especially in the e-commerce, right? In the e-commerce research, recommendation and search system of the e-commerce company, right? So later I joined Tencent, and I was the engineering lead behind the WeChat search engine, right? So if you use WeChat, then you notice that there's a search box which basically allows you to search any kind of things, right? It's not like Google search, but it's more like, let's say, Facebook search, because you are searching in a closed domain, right? So Google search is basically leveraging all the link information from page to pages. You probably heard of this page rank, right? So kind of like a Markov chain, all these kind of things, right? And then you can use this information to weight the pages, right? You weight whether this page is more like related to the more credible than the other pages, right? So you kind of use this page rank to weight the pages, right? And but when you do search in a closed domain, closed ecosystem, where you don't have this kind of linked information, right? So you never see that this Facebook post is linked to that Facebook post, right? You rarely see this kind of information, right? Basically, each Facebook post or each tweet, right, is kind of independent from the others, right? So it's completely independent. Right, and then so then how do you rank the quality of the search result? How do you build your search system without having this kind of PageRank system, right? So when you build a search system there, so mostly you rely on the content. You rely on the content analysis. You try to build your machine learning model on the content, and then try to rate the content relevancy, right? Instead of raise the link relevance. Right, so that's kind of my work during 2 years, in my last 2 years at Tencent AI Lab. So I was building the infrastructure there, search infrastructure there. And so that's kind of the background. So some of you may, when you learn machine learning, you probably notice there is a data set called Fashion MNIST, which basically contains all the closest fashion articles. So that is actually created by me. I also like the author of the Bird Eye service, which is also very popular repository back in 2018. Right? And yeah, so today's, as I said, I want to give some lessons learned and viewpoints on the on the overall AI development, which such big topic. Right? So this can be, usually I want to give this talk in 4 parts, right? So transfer learning, how does affect our daily life, and AI engineering, and open source plus AI and AI marketplace. But due to the time constraint, so I will just give the the first and the second part of this talk, and then for the third and fourth part, probably save for the next round. All right. Oops. Okay. So let's first talk about transfer learning, right? So if you kind of like if you work in the machine learning field, you must know transfer learning. It's kind of like a very hot topic in the recent years. But if you don't know about transfer learning, then don't worry, right? Because I will briefly introduce you what is transfer learning. So, but my point here, right? So I want to make the conclusion first, and then elaborate the rationale behind this conclusion. My conclusion is transfer learning is changing your AI more than it's changing AI industry and also the landscape more than you think, right? Okay, so let's first, for those who don't know so much about transfer learning, so let's just give you a very short intro, a definition. What is transfer learning? Right? So transfer learning is one of the hottest topic in 2018 to 2020. Right? So it's listed under the top, one of the top trending topics in the machine learning or deep learning community, right? Among with like graph learning, meta learning, and reinforcement learning, right? And so the basic idea of the transfer learning is when you, I'm assuming that you know what is artificial neural network is. That's because this is kind of like back in 1960s, we already have this neural network, this idea, right? But then this kind of like it rise and falls and renaissance and so on. And so it's like it has a long history, right? So you should already be aware that there is a machine learning algorithm called neural network, and now today it's kind of like the mainstream of machine learning algorithms, deep neural networks. Right? So transfer learning is basically a technology that built on top of the deep neural network. Right? So when you usually try to solve a problem using machine learning, or try to bring some data intelligence into using machine learning or using deep learning specifically, right? You always need to train a model, right, to fit on certain data, right? So that's how the machine learning works, or how the deep learning works. But transfer learning basically saying that transfer learning describes the knowledge as a parameter of the network. Right? So because once you train the model, so what you're actually doing is to feed all these parameters, to feed all the weights in the model, so that the model becomes like can describe whatever the mapping between the original data and then your objective. Right? So this is kind of like the basic idea of neural network, right? Try to find a mapping by parameterize your function, right? And try to find the best parameters that describes its functions. Right? So this is a neural network. And then, so one can say that, okay, so the model doesn't learn anything, it just learn a bunch of parameters. And this bunch of parameters is basically the knowledge, the so-called knowledge of the model. And so the transfer learning basically saying that, so instead of training the task, finding these parameters again and again on each individual task, you can just train it once and apply all, right? So what does that mean? So that means, let's say you have 2 tasks, task A and task B, right? So you can basically train your network on task A, right? And then you get the parameters of your model, right? And then you copy just copy and paste the parameters into the other network, which is supposed to run on task B, and this will work. Right? So this will work. So of course it doesn't work out of the box, right? So then basically transfer learning basically provides a methodology that to make sure this copy paste will work, right? So this is basically to give you a very, very brief introduction of transfer learning. So in summary, knowledge is defined as parameters in neural network, right? And transfer learning basically saying that defines a copy paste pattern where parameters can be shared and reused in other different tasks where you don't need to train the model from scratch. You can just copy the parameters and paste the parameters in your model, and this will work, right? And therefore, so where the transfer come from is basically by copy paste the parameters, you in some sense copy paste the knowledge from one model to another model, right? So that's where the transfer learning comes from, right? And so in short, in one word, so if people ask you, like, if this is a question, or if this is like an exam question, or people ask you, then what is transfer learning really about, right? Can you use one word to summarize what is transfer learning? So basically, transfer learning solves the reusability problem of deep learning, right? So previously, when you try to use deep learning, let's say your boss give you a task about recognizing cats and dogs, right? And then you need to bring you need to train a deep learning model that recognize cats and dogs, right? And then your next day, your boss gives you another task telling you to recognize a traffic light or do some autonomous driving, right? And then you have to do another task. You have to train another model in autonomous driving, right? But transfer learning basically saying that, oh no, you don't have to build something from scratch. Just use your cats and dogs identification model to use for autonomous driving, which pretty makes sense, right? So that's what could possibly go wrong by using cats and dogs model. Right? But anyway, so reusability is a key of transfer learning, right? So I will keep bringing this word later, but let's hold it here, right? So let me just I want to tell you another, kind of like a story behind transfer learning to help you understand why reusability is such importance, right? So back in 2018, back in 2018 September, Google released this BERT model. It's called bidirectional, whatever this, I forgot this name. Bidirection, some representation, attention, whatever this transformers, right? So this is kind of like this very groundbreaking model. So what does it do? Right? So first of all, it's a natural language processing model, right? So it's basically describes the it's a kind of like model where you can use for natural language processing task. It's not for computer vision, it's just for natural language processing, right? And so basically, if you look at the word, there's a community, right? Before the BERT model and after the BERT model. And then you will realize that this is not just a model, it is the model that changed the world, changed the community. At least change the community, how the AI community sees the world, right? So if you look back, right, look back all the models, all the NLP models that before BERT, most of them, 90% of them fall into this category. So basically, they want to train an end-to-end model that solves this particular task, right? So you have task-related data. Let's say you have a bunch of newspaper and then newspaper text, and then you want to classify the class of these newspapers, right? So, and then you train a classifier, right? So let's say support vector machine or whatever naive Bayes, and then you train this classifier to get this task done, right? So basically, by doing that, you are actually doing an end-to-end model, right? Because you solve your problem from end to another end, right? So you solve this like a end-to-end, right? After BERT, what Google BERT provide is another kind of like a philosophy, right? So instead of solving the task end-to-endly, you kind of break down the task into two parts, right? So the first part is pre-training, and then the second part is fine-tuning. So pre-training can be done not on your task, right? But on some very general tasks there you have enough data to train a very generic model, right? And then in the fine-tuning task, you kind of like refit this generic model into that specific niche or that specific domain, right? So think about this. Back to the newspaper classification example, right? If we break this down into pre-training and fine-tuning, we can do something like this. We just train whatever this language model that can predict the next word, right? Based on all the human English, English literatures that we have, based on all human history, right? So we have a lot of data to learn from, right? And then once we have this kind of general model, then we can fit into the newspaper recognition or newspaper classification task, where we just need to slightly change some of the parameters, slightly to tune some of the parameters in order to make this generic model more fit to our particular need, right? So that's kind of the idea, right? That's kind of the idea of pre-training and fine-tuning, right? Yeah. So it is very groundbreaking because I was like, and also very influential because I remember back in 2018 when I was at Tencent, I actually built after 1 month after Google released a bird, I actually built a wrapper around bird called bird as service, basically wrapping the bird model as a kind of like a SaaS service so that people can use it by just calling the API, right? And then doing all the encoding job, right? Like a text encoding job. And then it was very popular back in Tencent, and a lot of departments at Tencent, they're actually using it as one of their kind of like machine learning backend server or something. Right? So it was it was pretty successful story. Okay. So after that, after Google Bird, there are a lot of other models, like a bird-inspired models that focus on the reusability of different domains, right? So such as the computer vision, you also have kind of like this vision like a ResNet VGG, which basically you can also have this like a pre-trained phase and then fine-tune on specific tasks, right? So if you think about this, it also makes sense, right? So like for example, recognizing cats and dogs and autonomous driving, right? So what is the common stone between these two tasks, right? Can you make a guess? What is why can you transfer the knowledge? Why can you pre-train a generic? So what can be the common, let's say, the common knowledge between recognizing cats and dogs and the autonomous driving, right? So the common knowledge is how the model see basic fundamental concepts such as color, such as texture, right? Such as shadows, right? So those are the very common knowledge that you will handle when you do a computer vision task, right? It doesn't matter whether it's cats and dogs or it's autonomous driving, right? So what is a line? What is a curve? What is a square? What is a circle, right? So it's a basic shape. Now you want the model to have kind of understanding about this kind of basic fundamental knowledge first before they can recognizing cats and dogs or before they can do autonomous driving, right? So that's kind of the idea of pre-training in computer vision, right? And same goes for audio, right? Audio recognition, audio auditing, and so on. And recently, Google just released the DNA model, which basically allows you to pre-train on this DNA model, right? So, okay, so in summary, as I said, transfer learning solves the problem of reusability in AI, right? So some of you may still not really sure, so what, right? So solving the reusability of AI, so what? It doesn't sound very exciting for me, right? But it is quite a big deal. So if you think about it, right? So if you go through whole human history, right? So look at the old days where the caveman built kind of like axe to fight monster, not fight monster, to fight animals, and then we have these this steam machine that powers the industrial revolution, and then we come to the software engineering, that basically is the fundamental things for today's IT industry, right? even when it comes to the this rocket science, right? So where people have to recycle the space shuttle for the next run, right? So you always care about the reusability, right? The reusability actually powers today's civilization, right? So you want to use your axe, on the one hand, kill the animal to get food. On the other hand, you want to cut the tree to build your house, right? So, but same with the same axe, right? So that's kind of the reusability. You can say that our civilization today is built on top of reusability. And especially when some technology is coming to reach a point where people already think about the reusability of this technology, this will give the exponential bump on this technology, on the adoption of this technology, right? So that's why reusability, that I highlighted this a lot during my talk, right? Okay, so but transfer learning also kind of like solving the reusability problem on the one hand, but also generate some problem, right? Also generate some problem. Has some bad effect, which affects all of you, right? So which affects all of you. So why I keep saying that transfer learning is a game changer, right? Because if you think about the training of such very generic model, right? So you want to recognize everything, right? You want to have some kind of like a very generic model that trained on all human literatures, whether it's English and Chinese or German. In the end, this kind of generic model can understand all natural language, despite whatever this language it is, right? It can understand all, but gives you occasional performance. Let's say 70% of accuracy, and then you have to fine tune, right? So this makes sense in the domain, in the concept of transfer learning. You want to have a very powerful generic model, and then you want to fine tune on specific niche, right? So that makes perfectly sense. But in order to get this very generic model, you have to spend a lot of time to train that model and spend a lot of money, hardware, to train this model. And also, of course, spend a lot of resources, human resources, doing try and error, all this kind of things. And this actually, if you compare to today's like AlphaGo, this kind of from Google to play the Go game, to the first neural network model that we had back in 2003, I believe, AlexNet. All right, so the training cost is like 1,000 times higher than before, right? So the time, the money that's spent to get a good model, it is much more expensive to get such very good model, right? And this actually generates some paradigm shift, even for the labor force in the AI industry, right? So basically, you will observe a lot of AI researchers. Initially, they want to do some groundbreaking AI models, but in the end, they end up doing some engineering things because they cannot afford either the time or the money to build a model from scratch, right? This is pretty understandable. I mean, who has time, right? So you see that Google, announces BERT model or whatever is this model, but those are the, how many people, how many researchers are in Google, right? And every day you only have this handful of papers that are coming from Google that giving you this groundbreaking new models. And how many of the models are dead just internally? It doesn't work, right? After you spend 6 months is tuning the parameters, this model doesn't work, right? So a lot of people actually, found that building something from zero, from nothing to one, it actually, the cost is so expensive that they cannot afford, right? Who has time? And then they move to the one-to-N, this innovation. So basically care more about reusability, engineering, scalability, applying this to a specific domain, right? So I would, when I work at Tencent AI Lab, right? So I was, the AI Lab is kind of like the one of the very AI-driven department in Tencent. So there we have 300 people in AI Lab. And the total number of employees in Tencent is 60,000, 60,000. And then if you count only the engineers, then Tencent has 40,000 employees 40,000 the engineers at Tencent, and then we are one of the 300 out of 40,000 employees that really working like a day-to-day working on AI. Even for us, like this 300 people, not every one of them building like a GPT-3 from scratch, right? They are not building something like this. A lot of people are basically modifying the model a little bit and then try to patch this model a little bit and then building some incremental research advance instead of building something from scratch, right? So in the end, this is a picture that I posted in my blog back in 2018. Back in the days, I was saying that the transfer learning changing the AI landscape so much that in the end it forms a new AI supply chain, right? Sounds very big, right? So, but back in the days, like people, this doesn't, not so many people understand this picture, right? So, but if you see this in 2021, if you see this from today, then things to become much more clear, and you start to think, oh, this Hannah is right? So about this supply chain change, right? So let's look at this picture, right? So I said that because of the transfer learning that counts more about reusability, and also it increase the cost of building something from scratch to something that is not affordable by everyone. So this push away a lot of engineers and researchers moving to engineering part, to AI engineering part, right? And pushing away to the one-to-N innovation, right? And in the end, only a very, very small number of people from those big tech giants, they have the time, energy, and the money to build something from scratch. And what their output is actually what I call this pre-trained model, right? So their primary responsibility is to do groundbreaking research and deliver a pre-trained model. So what a lot of engineers, probably including many of you in the future, when you go into the AI industry, is basically using this pre-trained model to patch your knowledge into this pre-trained model to use this pre-trained model in your own domain, right? Whether it is not autonomous driving or smart speaker or whatever domain, right? So you try to use a pre-trained model and make sense of it, right? So that's kind of the the new supply chain, right? Okay, so So please remember this graph, but if you don't, right? So don't worry. So because I will bring this graph later, I'll try to explain this part by part. Okay. So the second part, the second topic that I want to bring to you is, the engineering, the importance of engineering. Right? So I don't know how many of you are like PhD students or doing, want to do a PhD in Munich or in whatever university, right? So a lot of PhD students that I know of, that they have very strong, like kind of like a, I don't know, ego, and they don't like engineering so much, right? So they want to lock themselves in a small room and then doing research paper. Right? So that's kind of like the stereotype of PhD students, right? So they don't like all the software engineering stuff, and when it comes to some Docker, this kind of virtualization, they think this is pretty irrelevant to them, right? So my point here is, again, I want to bring my conclusion first, is engineering is your friend, right? Not your enemy. Right? So to elaborate on this topic, right? So to elaborate on my point, I want to, probably after you heard my talking about transfer learning and how it's impact, the AI industry, the landscape, how it defines a new AI supply chain, you probably feel a little bit sad, right? Because you found yourself, you want to do groundbreaking changes to the AI. I mean, there's no wrong about that. Everybody wants to do groundbreaking changes, right? But then you realize that building something from scratch is very difficult, right? So because you don't have GPU, you don't have as powerful GPU as Google does, and also you cannot waste your like 6 months on nothing, right? So that's pretty understandable. And then if you want to change to one-to-N innovation, which focus more on the reusability and engineering, but then you don't know how to start engineering something, right? Because you spend a lot of time on understanding the AI models, understanding how the algorithm work, but kind of ignore the fact that this algorithm works only because there is software that supports it. And eventually, when you try to apply some pre-trained model in your own domain, right? Let's say in the drug funding, right? So in some kind of like a DNA or chemistry or whatever this specific domains, you also don't have certain knowledge in that domain because you majored in computer science. I just talked to Leanda and Florian, and they said that most of you come from computer science background. You are not majoring in chemistry, you are not majoring in physics. Right? So when you try to apply a deep learning model into this domain, and then you found that, okay, so I'm completely like dumb, like in physics or in chemistry. So you have nowhere to start. So this kind of like makes yourself like question yourself, like how do I still join the wave of this new AI landscape? How do I position myself in the AI landscape? So my conclusion here is this is actually the best time for doing AI engineering, right? And to elaborate on this point, so let's again look at the this supply chain, but this time I will decouple this into 3 parts, right? So I will decouple this into 3 parts from the right-hand side to the left-hand side. So let's first look at the first part where I just highlighted it with the right block. Right? So building something from scratch, from 0 to 1. So if you look at this part, look at this journey, then you immediately realize that people, what kinds of tools that people need to use for building something from scratch, right? When building something from scratch. If I ask the question, like what machine learning package or what machine learning framework have you used back in 2000, I don't know, 2014, then people will get a lot of answers, right? Like I don't know, some like a Cafe, that's a piano, this kind of very old machine learning or scikit-learn, or this kind of package. But nowadays, if I ask the same question, what kind of machine learning framework are you using to start with AI, right? People will just give me 2 answers, right? TensorFlow or PyTorch, right? So there is no other options. There are other options, but you don't want to be part of them, right? So you want to kind of like stay yourself in the mainstream, right? And so that's kind of the de facto, framework for building something from scratch, right? So if you see from this perspective, you see that also TensorFlow or PyTorch, they are just software. Right, but if you think about their meaning, their purpose, and their impact to this AI industry, they are way beyond just a software, right? They actually define the design pattern of how you see AI, right? So to give you an example, to understand that, so let me say that today I want to give you a homework where basically you need to build a classifier that can recognize cats and dogs, which later will be used for autonomous driving system, right? But let's say, okay, so you want to build a classifier that recognizing cats and dogs, and then the first thing that you came back home, and then the first thing that you do is go to TensorFlow or PyTorch website to find examples to learn how to build such classifier from scratch, right? I believe most of you will do this instead of going to library and find a literature and then read deep learning chapter by chapter and then eventually come up with a solution by yourself, right? So in this sense, a lot of people knows about AI, knows about deep learning or AI, right? It's really come from the documentation website of TensorFlow or PyTorch. It's not from the literatures, right? So in that sense, they actually already defines how you think and how you build AI software in today. Right? So that's very successful as a software, because most of the software are being used by people. They hardly define how human behaves, how humans think a thing, how human formulates a problem, formulates a solution to solve a problem, right? But TensorFlow and PyTorch managed to formulate the design pattern of human to solve a problem, right? So that's kind of like a very incredible thing as a software, as engineering, right? Yeah, so here I said that as a universal framework of AI applications, and also kind of like today's design pattern of artificial intelligence, right? We still see there's some like a framework here and there, but it's very, very hard to squeeze into this market, because this framework today is not beyond. I keep saying there's a software, right? But they actually set up their roots already in this AI landscape, and they kind of develop in vertically, right? In vertical way. So what does that mean? So TensorFlow right now is optimized for its own hardware, like a TPU, right? And then you have a very best experience when you use TensorFlow with Google Cloud, or when you TensorFlow using Google Colab, right? And so you see that the software is actually moving vertically, try to set up the barrier to protect itself, try to lock the user into their ecosystem, right? By providing the hardware, the edge devices, and also the cloud service, right? They try to lock their users into their own ecosystem, right? And so therefore, today, if you want to compete with TensorFlow and PyTorch, just having a software is probably not enough, right? Because you first have to compete with their community, compete with their design pattern, and then you have to compete with their hardware, right? I'm not saying this is impossible, because I know there are some companies that are doing this, but it's just extremely, extremely hard. Right. Okay, so let's look at the second stage, right? So we're basically, what is the second stage anyway? Oh yes, the second stage is basically you want to have a pre-trained model, and then the rest of the AI community basically try to get this pre-trained model. So that's kind of the first step, right? And then once you get this pre-trained model, and then you can apply this to your own domain, right? So to your own domain. I don't know how many of you know Hugging Face. So if you work in natural language processing, or if you use natural language processing as a kind of like a pipeline, as a part of your pipeline, so you probably know this company, right? It's very popular, and it provides very a very popular, very easy to use software called transformers, right? So where basically you can find a lot of NLP models that can be used out of the box. So for me to understand, why Hugging Face is so popular, is basically I recently just thought about this, right? So, and I came up an argument that saying that Hugging Face is popular because Hugging Face nowadays is successful is because it solves the accessibility of the pre-trained model. It solves this problem, right? So how to understand that? So if you think about the days before Hugging Face and the days after Hugging Face, right? So days before Hugging Face, when you want to use a pre-trained model, right? So you always go to, like, for example, Google Research, Microsoft Research website, or some university research website, and download a zip file, right? And then you decompress this zip file on your laptop, and follow some README from the original website. And if it doesn't work, then you have to ask the professor, you have to shoot a mail to the professor, to the research team from Google and Microsoft, ask, what is wrong with this file? Is this broken? Is the link broken? Or something like that, right? And usually, when you found something there, and I'm pretty sure that a lot of you face a problem when you shoot a mail to a research team from a university, and then the university email just auto replies that that this person doesn't exist anymore. He probably already graduated. He left university already. All right, and then so you have to set up your local environment, doing GCC, all the compiling stuff on your laptop. And the best part is when you switch to another laptop or computer, you have to do all these things again. Right? So that's kind of the days before Hugging Face, where you want to use some state-of-the-art machine learning model, pre-trained model into your own to solve your problem. Right? So that's kind of the. And after Hugging Face, things become very simple, right? So Hugging Face basically provides a kind of like the very Pythonic API that allows you to just from Hugging Face.model import Google Bird, and then you can use it directly, right? So 2 lines of code versus like half day of work, right? Half day of non-reproducible work, right? So you have to do this again and again, right? So you can see that Hugging Face success, as I summarize, is about making AI pre-trained model accessible to everyone, right? So Hugging Face basically realized that, okay, the need of accessing a pre-trained model is so strong that every developers, not just the AI developers, right? Every developers, software developers will need, right? And it pinpoints this problem and solve it very nicely. So if you think about this, it's not really an AI problem. It is about making the model accessible to everybody. It's more like a, I don't know, CDN problem, right? Where you want to distribute some file to make sure that everybody in the world, no matter where they are, they can they can visit and download this file with very high speed. And they can use this file directly with some wrapping, right? So without some trouble, right? So that's not really an AI problem. It's more like a accessibility and usability problem, right? But Hugging Face managed to do this, managed to solve this, very elegantly, right? So that's why it becomes successful. I mean, of course, it has a very other successful products, but for me, I'm just analyzing the early stage of Hugging Face, So I'm not like the part of the Hugging Face. Like I just want to keep my friends close and keep my enemy closer. Right? So that's kind of why I have to analyze the Hugging Face strategy. Right? Okay, so anyway, so the I think the Hugging Face story also is about they care about the usability of their framework, of their software, which is super important. Right. A lot of people, when talk about usability of a software, they always think about the consumer-facing software, where you have an interface, you have a graphic user interface, and then you want to move the button from the left to the right, and you want to shrink the size of the button by 2 pixels, or you want to set the margin, the padding, and so on CSS, right? So via CSS. So that's kind of like how people generally see the usability, right? As a software engineer, right? Because especially as a product manager, right? So when you always get used to, oh, this app is so slick, right? It's so smooth that it just has this kind of easy in, easy out animation. So it has a very strong usability to the consumers, right? But that's kind of like in the consumer facing kind of like a word. So you have this kind of idioms to describe usability in that way. So that makes perfectly sense. But think about this. I'm building an infrastructure software. I'm building machine learning core, a framework. What does usability here mean in this context? What does usability mean, right? When I'm building an infrastructure software, what is usability? Right. So the usability is usually defined by the API interface, where you have some doc strings that basically provide some intelligence. You have very nice APIs that makes totally sense. You have a very clearly written documentation where people can follow and then reproduce the result without any trouble. Right? So that's kind of the usability in a nutshell. But if you zoom into this domain, there are a lot of things that you can work on, right? So let me also share a true story, right? So from my side, right? So you see, oh, by the way, yeah. So what I think I didn't mention too much about our company, what we are doing at Gina AI. So we're basically building open source neural search solution. So basically allows you people to search anything, right? Whether it's video, text, audios, PDF, 3D meshes, anything, any data types that you can imagine, using deep learning, right? So if you go to GitHub, if you search for Gina AI/Gina, right? So then you'll find our repository, right? So it's one of the very popular GitHub repository in the world. Right now we have like 10,000 stars, more than 10,000 stars on GitHub. So very popular. So please go check that and share with your friend and try to use that and also give it a star, right? So I want to tell a real story, like behind Gina, behind this, let's say the successful story of Gina, is that it's not successful, right? It's not successful because it's not as always successful as today. Right? So when we release, I mean, we built Gina, since last February when we found the company, and then we have the, we released it on GitHub since May 2020. And then for a very long period of time, it was, the adoption of Gina, it just linearly increased, right? I mean, it is good, right? So as long as it increases, it is much better than, just stay on as a constant, right? But when you're doing an open source software, right, and it is linearly increased, right, then you immediately know that it is something wrong, right? Because there is no adoption. Linear increasement means no adoption, right? Why I'm saying that? Because if you think that, assuming there is adoption of your software and people start to use that, this will generate the second kind of like the propagation of your software, right? Basically the people will tell other people that, oh, this software is very, very useful. It's pretty easy to use, right? And then based on their, the social circle, they will generate another kind of wave of propagation. And this eventually, the whole users, the number of users will go exponential instead of going linear, right? So basically, not exponential, but at least the super linear, right? So at least super linear. So if you see your software, especially open source software, goes always linear, especially if you are open source company, and then your software is kind of go all linear around, and then you notice that there are some problems, serious problems about the adoption, right? And then we realized that, and then we kind of like start to have the idea of having refactoring on, on the Gina framework can part like removing some of the APIs and so on, and we released Gina 2.0, right? Which is like a huge improvement in terms of the API and usability, right? And this we see a huge adoption, like goes as a super linear, right? So that's kind of a very significant from the graph, right? So basically on the in June, around June this year, we released Gina 2.0, and it will drives like crazy, right? So what we did actually is just simplify the API, improve the usability, right? So if you look at Gina, the technology stack of Gina, so actually it cuts the neural search application into 7 layers. From the bottom, you have the network and competition layer, which is like the very hardcore NumPy and 0MQ gRPC stuff. And so let me just play this animation again. I really like this animation, right? And then on top of that, we have data types, and we have logic layers, and then we have runtime, we have microservice, orchestration, and finally we have application. And so these are like 7 layers, right? Why Gina provides the 7 layers in the first place? Because we realize that, based on my experience working at Tencent, and also like all the software engineering and also AI engineering experience, if you want to build a deep learning powered search, right? Eventually, you will end up with this technology stack. You will end up with the 7 layers. It's not something like I want to just, just to scare you or want to brag you about, the 7 layers, how awesome we are. But it's just the fact, the matter of fact that eventually you will wind up something like this, right? Okay, so this 7 layers, very cool, very awesome, right? So it looks like a looks like a very hardcore thing, right? Why can't the developers like it, right? Because the developers think that this is too complicated, and most of the layers are actually meaningless to them, right? Eventually, what we did in 2.0 is basically can be summarized in just one simple graph like this. We basically hide some layers out of the 7 layers and basically only promote 3 layers, only makes these 3 layers, basically the data types, the logic and orchestration, visible to developers, right? And that actually solves a lot of problems, right? So then the developers immediately know that, okay, in order to learn Gina as a framework, you only have to learn the 3 concepts, right? So data, logic, and orchestration. That's enough, right? So you don't have to learn all the other things. All the other things are kind of like a hidden, they're kind of like a playing in the shadow, and then just help you to accomplish some task, right? But you don't have to know them. You just, you don't have to be aware of them, and so that's kind of the success of 2.0. I mean, this is like a very, let's say, a very easy way to say that, but eventually underneath there are a lot of hard work behind that, right? Okay, so in summary, so what does usability mean in terms of the AI, or when you build an infrastructure software, when you build like an AI machine learning core, usually you need to put some consumer, this kind of consumer business mindset, right, into your framework. Basically, you consider API as a kind of UI, right? So let's say the perfectionism of changing 1 pixel to 2 pixels, this kind of mindset need to be transferred into the API, when you design the API, you also have to carry this mindset. You also have to see it on the other side of the table as a developer, as a user of your API, and feel from their side, right? And the second thing is, my own point is probably very radical to a lot of people, is that I always say that Gina is not built for 30 or 40 years old people. I mean, they are already goners, right? I don't want to build software for them. If they want to stick with some technology stacks, then so be it, right? Because I understand they don't have so much time, not so much time when building, keep writing software, right? So what I want is my software to be well accepted by Generation Z, by Gen Z, right? So that's kind of like a very bold idea, right? But I keep telling my team, right, that if today I give a talk, right? So I give a talk, I walk into any like a random German high school, right? And then give a talk there about Gina. And if after 40 minutes talk, and these high school students can use Gina, then I will feel very accomplishment, and will feel very excited and happy, more than if I walk into a Google office and give a 40 minutes talk and convince those stubborn engineers to use my software, right? So that makes me more happy, right? By convincing the new generation, the Generation Z, by convincing those high school students or even middle school students to use my software, to speak my language, because they are the future, right? You are speaking their language, and you kind of lock those users for you in the future, right? But that's just my personal idea, so you can disrespect it, right? Anyway, so the last one, so back to I hope you still remember the AI supply chain stuff after all these crazy talks. And so the last part of the the delivery is the last part of the journey, the supply chain journey, is about delivery, right? So it's about once those people get this pre-trained model, how to make sense of this pre-trained model in your own domain. So that's kind of what I call is last mile delivery, right? So because you already get your pre-trained model either from Hugging Face or use good old fashioned, good old stuff like downloading from some HTML page using Internet Explorer, and then either way you get your pre-trained model and then you try to make sense of it. So that's the last mile delivery. So why people need that? Because as I said, right, back to the topic, back to the first topics that I mentioned, transfer learning is good. Transfer learning breaks down the machine learning into pre-training and fine-tuning, right? But eventually, when you only have a pre-trained model, you only have this okayish performance, right? So you only have like a 60, 70% of the performance, which is good, right? So you cannot say it cannot do anything. It can recognize cats and dogs, right? But are you really confident enough for that to use it for your autonomous driving, right? Of course not, right? So you have to fine-tune the model into your own niche, right? So that's really the most important part. Right, so that's actually, you can say that it's actually brings the performance from the 70% to 99%. Right, so that's kind of the task for the last mile delivery. Right, and the most important thing is this is your chance. Right, so this is your chance to make yourself valuable. Right, to play a lot of tricks, a lot of technology inside this last mile delivery. Right, because people will pay for it. Right, a lot of people. They kind of like take the free things for stuff, but you know that the free things is not, it does not give you the premium experience, does not give you the premium accuracy or precision recall, this kind of things. But people will pay if you can somehow manufacture this free stuff into something fancy, right? They will pay this extra cost. And then, this is a part of the thing that you can monetize, right? So if you can provide such thing that allows people to fine tune their model, right? And then this will give a lot of people, a lot of confidence about using their model in production, right? And this confidence will, encourage people to pay for your products even more, right? So why I'm keep saying that this is still your chance, because I believe when it comes to fine tuning, you need another tools besides TensorFlow or PyTorch or Hugging Face. Because if you think about the TensorFlow or PyTorch, right, their position is about, as I said, about solving the 0 to 1 problem, right? Solving the 0 to 1 problem. And using TensorFlow and PyTorch to fine-tune a model, to fine-tune an existing model, I'm not saying this is not doable, or this is doable, not doable, but it's just the overkill, right? Because you already have the model architecture, you already have the weights in the models, you don't want to change this dramatically, right? So a lot of features that in TensorFlow and PyTorch, they are not necessary. What are necessary is you need a tool that somehow can keep human in the loop, right? Keep your domain knowledge and pass or integrate your domain knowledge into the model. And the smoother this integration is, the better this fine-tuning tools is, right? And of course, the better results you can get, right? So that's actually the chance, right? So where you can you can design some tools that for fine-tuning for your specific domain, right? Okay, so, and by the way, so we also just announced a new product called Fine Tuner. So if you go to our GitHub page, and then you will see that there is a tools called Fine Tuner, which basically doing this thing, right? And yeah, so to recap, so to recap the whole AI supply chain, right? So we have the big tech giants, only a small number of people in the big tech giants working on the 0 to 1 innovation. They use TensorFlow or PyTorch to build their machine learning model and deliver a pre-trained model. And then a lot of people, a lot of AI engineers, in this community, in this big community, will basically use some tools to get this pre-trained model, right? And finally, to use this pre-trained model after fine-tuning and then apply to their own domain. So what I see the biggest chance for every one of us, including myself, including my company, is to leverage the pre-training. Leverage the fine-tuning. Yes. So that's kind of the that's kind of the story that that I want to talk. Right. Okay. So let me see. Okay, so we are already all like a little bit over time. I hope you're still there because I cannot see how many of there, how many of you are still there. All right, but I want to talk like the three, kind of remarks that I have like a random thoughts when I build the company over the years, right? So I want to first talk about the one thing is the capacity. The capacity matters. So what does that mean? So the capacity usually, when I say capacity, is about the software capacity. So specifically, it's about how many people can simultaneously work under one project, under one repository. So this is what I said about capacity, what I define as capacity, right? So so why does it matter? So for example, I don't know how many of you live in the dormitory before, right? So student, like a student house, a student apartment. I know in Germany, like usually you have like just one person per room, but back in China, we have 8 persons in one room, right? So 8 persons in 12 square meters. So that's unbelievable. Is if you put into today's pandemic. But back in the days when I was doing undergraduate in China, so I slept with 7 other people in one room, just in probably 20 square meters or something like that. So it's a very small room, but everybody kind of like they keep the room very tidy and very clean and very organized, so that you never feel that this is a small space, right? But of course, after you graduate, after you grow up, and then you kind of like you found your own apartment, and then you never found it big enough, right? The reason behind this two difference is that the right-hand side is the room that you have at the moment, right? It is your room at the moment, and then you never get this very organized as in the student room before, right? And that's actually basically set up, basically tells you one lesson is that, if you want to have a lot of people working on the same project or stay in the same room, you have to architecture your software in a way that you provide a lot of layers in this software, right? So that's actually the reason why we have the 7 layers back in the days when we architecture Gina, because we want to speed up the development, and we want more people to join us and then build this software as open source software, right? But it is not just as easy as saying, now we are building open source, please just join us and then let's build this beautiful world together, right? It doesn't make sense. Why? Because when a lot of people join your software and build the software with you, everything becomes chaotic, right? That people change this part of the code will affect that part of the code, and everything will become breaking changes, and this will become a mess. Eventually, your software just dead because a lot of people working together, and nobody actually, make any meaningful contribution to your software, right? So the way to solve that is to clearly define, to clearly have the capacity in your mindset when you're architecturing a software. This is super, super important. If you want your software to be sustainable in the long term, try to define this clearly, right? Try to architecture, try to increase the capacity from time to time. It's not a one-time thing. Like, from time to time, you have to refactor your software to make sure that more and more people can join your software and then build these things together, right? So this is the first point, right? So, and the second point is about, it's a very popular term in China, which is called involution, right? So involution versus evolution, right? Involution basically means that you kind of like stuck in your own position and then try to optimize out very small detail things, but in general, you get a kind of very marginal benefits from that, right? When it comes to AI engineering, right? Because it's kind of like squeeze or some kind of like a twist of these two parts together, because AI is mostly about researching, advancing this kind of exploring stuff, and engineering is about reusability and scalability and so on. And so you kind of like a squeeze them together, and eventually you build a kind of like have a team that not really brave enough to go forward, but instead of keep doing refactoring all the time, right? So that's very common. So if you lead a team one day, so you will face a position where everybody just too afraid of pushing things forward because they are afraid of breaking something existing, right? They're afraid of breaking something existing. And they keep modifying the code, refactoring the code here and there, but forget what they really should target at is in the front, not here, right? Not here, but in the front, right? So that's kind of the kind of like the the difference between the paradox between the involution and evolution, and then you as the software architecture or the architecture of your project, you have to make sure you can balance these two things. The other thing is, because I work in open source industry for many years, and I also have some successful open source project. So I want to just highlight the last thing is basically the expectation management. Whether eventually when you're after graduation, you want to join the company, or you want to build your own open source software, or you want to start your own business, creating a startup, and so on. I think the most important thing for you as the manager or as the kind of the leader or as the entrepreneur is to understand the importance of expectation management. So what does that mean, right? So let's say you as a software leader, or you have the architecture, you are the architecture of your software. What you have in your mind is basically the middle picture, right? It's the second picture in the middle. So this is very shiny building is what you have in your vision, either as an entrepreneur or as a kind of the leader of a project, right? But when people join, when you really start to build something, right? So when you start to build something, or when you start a company, so you eventually basically are doing a lot of like fundamental work, like construction, right? So from the bottom, right? Only you know that this construction will bring us to, right? You know that, oh, we're building this kind of construction area, and people work with their hands dirty because eventually we will grow up as this big shiny building, right? But nobody else has this vision as you do, because you are the leader, you are the architecture, you are the entrepreneur of this company, right? If other people have this kind of vision as you do, they probably will just replace you as a founder, right? So they will just go to elsewhere and then start their own business, right? And so you only have those people, who cannot really see what you see, right? But they keep doing this fundamental work. Then one day they will question you about, what's the purpose of doing all this construction, right? And especially when you bring your product, whether it's a software to the community, or it's a kind of like a project to the clients. Usually the community or the client will expect some kind of very nice, shiny lobby where they can just, sleep on the bed without worrying about anything. There's a very nice lobby guy, lobby boy will just help them to check in and so on, right? But eventually when they move into your hotel, it's like, it's just a construction that you don't even have a bed, right? So they have to, they have to sleep on the ground, or they have to buy their own bed. Right, so that's kind of the expectation disalignment, right? Expectation misalignment between you as a leader, and between your crew, between your team, and also between the stakeholder, right? So the consumers or clients of the community. So how to balance that, right? So that's kind of the thing that I want to point out, which is super important. That you realize this kind of challenge from the very beginning. Okay, so that's kind of like the end of my talk. I just want to end with one remark, is that if you haven't heard of what I said, right, so still feel sad about choosing to do AI engineering because you somehow lose your prestigious of doing AI research, don't be sad, right? So engineering is not so bad. After all, right? So because engineering is a big deal in the human history, whether you are a caveman like using hacks to build your house or kill animals, or comes to the vast machines that powers the steam machine that powers the industrial revolution, or to the rocket science. We can say that our civilization today is built on top of engineering, right? So that's the end of my talk. I don't know if someone noticed the humor here, because for this slides, I reuse the slides that I talk about the reusability. right? So that's kind of like a very nice ending. But because this is not a kind of like an in-person conference, so I cannot see your smile on your face. Right? But anyway, so that's the end of my talk. And so if you want to hear more about about me, you can just search for Xiao on LinkedIn, and you can find my LinkedIn, and or you can just follow us on Twitter. We also have a very like a 2,000 people Slack community where we have a lot of Gina developers or Gina users basically using our software to build awesome neural search applications. So you can join. You can go to slack.gina.ai and then found the big community there. The best part is, it is open source and we build things in public, so you can also contribute to the project. But if you want to work open source in full time, right? So either as internship or you want to say that, okay, so after I graduate, I want to join Hans company because it's so awesome, and then just just contact me and shoot your resume on career.gina.ai or jobs.gina.ai, and then you can find their jobs here. We actually offer a lot of jobs because we are expanding so fast, and next year we'll set our office in San Francisco, and things were happens very fast, and really I personally really wish to talk to more and work with more young talents engineers that want to push AI to the next level, AI engineering to the next level. Okay, so that's the end of my talk, and so I will hand over to the host, and let's see if we have some questions.
Great, thank you very much for having this exciting presentation and for having you here to share your passion, obviously, and your expertise in this area. I think there is someone raising your hand, so I will just allow unmuting yourself. So yeah, feel free to unmute you.
I have one question regarding skills. In your opinion, what are the most overlooked skills in the AI industry that people forget about?
Oh, this is a this is a very nice question. So I would say, where do I begin? I think there are a lot of things that when you work in the AI industry, and especially when your ambition is to put AI into production, right? So you will see that you have to do a lot of work that is non-AI related. That actually brings to today's topic. The first thing about AI first is about forget about AI, right? So I think a lot of people know. I remember there was people say that a lot of people want to be the president, but nobody want to be the politicians, right? So it's kind of like but nobody realized that in order to become the president, you first have to be the politician. But it seems goes probably also the same here in the AI. When you want to deploy AI in production, when you want to have a nice, scalable, very responsible AI interface of very very nice looking interface and so on, you have to do a lot of engineering work that to support this technology, right? And this fundamental work, let's say the hard work that supports this AI technology to push that into public, this is often people haven't well prepared when they join the AI industry, right? And they probably think that, somebody else will just do this for me, right? But in the end, as I said today, this is the best time for AI engineering. If you can have this kind of more or less a full stack experience, from the back end to the front end, it is super important, super helpful for you to understand the whole pipeline, and this will help you to bring AI into production. The other thing I want to emphasize is the storytelling, right? I met a lot of engineers, right? Software engineers, backend engineers, front-end engineers. A lot of engineers are not very good at storytelling. So they're doing awesome work, but in the end, they speak like they're kind of like speechless when it comes to when it comes to the stage, right? So they are not very well prepared for presenting their work to the public, and this is super important nowadays. If you want to become a kind of influential engineers, either inside the community, inside your company, or inside the community. You have to talk more, right? I know there is a kind of like a, in China we even have a kind of like a, I don't know how to say this. It's kind of like people always say that show me the code, right? Like talk is cheap. Show me the code, right? Which I believe is very funny, right? Because eventually you have to talk to people, either talk to your boss or talk to the community, and then present your code, right? So that's the storytelling part is super important for engineers, and especially for those people who are willing to take your engineering level to the next step, right? To become one of the influential engineers in the world, right? You have to build your stories. You have to keep improving the storytelling of your project. Right?
Cool. I hope that answers your question. Before we dive into our Q&A on Slido, maybe this is a good point to take our pictures. So it would be cool if everyone opens the video cam and yeah, give us your best smile. Perfect. I see some people opening their cam, so we can post something on our socials. Thank you very much.
Thank you. I'm doing a screenshot now. Okay.
All right, perfect. Thank you. Maybe we can start with a question. I think, Han, you mentioned that on your last slide regarding the Slack community. So here's someone who is willing to contribute in Gina. So he or she asked Mr. Xiao, is there a simple feature that can be worked on by students? The project sounds interesting.
Is there a simple features can be worked by students for sure project? Yes, of course. I mean, this is also like a lot of people like don't like to work on the simple features, right? So everybody want to work on the big fancy features. But if you want to work on the small simple features, we have a lot, right? We have a lot of small simple features. A lot of times, I spend my time on changing the progress bar. The command line interface, you have a progress bar. And then in order to render this progress bar correctly, you have to spend some time on that, right? So that's kind of the simple features. It's not really important. It's not really hardcore AI skills, but kind of my daily work, right? And I think when you join I think the most important part is take the ownership, right? I see a lot of people. This is probably like a little bit over like answer the question, but it's like. I keep seeing people like working in this in the AI industry, AI landscape. They join as AI engineers and then they want to do great stuff, right? So but eventually every project has small features, has small tiny features that somebody has to do that, right? Somebody has to do the dirty work, right? Usually in the startup, a CEO has to do the dirty work, right? But I've seen a lot of people saying that, my enthusiasm for AI just dropped down dramatically when I start to build those housekeeping features, right? When I start to work on these housekeeping features. And then what do you do, right? As a leader, right? As yourself, like what do you see by working on this housekeeping small features versus by working on some awesome, like a world-changing, groundbreaking models? Because eventually, every groundbreaking, world-changing models or projects will eventually always have all this kind of housekeeping work that somebody has to do that, right? And I think the most important thing is ownership, right? And the most important thing is, do you see the ownership of the project is beyond your own enthusiasm on small things, right? On your own particular niche, right? If you believe that the product ownership is much greater than your own interest, right? Then you will polish it. you will do whatever small features that makes this project perfect, whether it is just housekeeping or there's some groundbreaking changes, right? So, but back to the topic, we have a lot of features that you can work on, right? Especially nowadays, we have the Gina, we have a fine tuner, this project, so you can go check out and then try that and then play with that, and then you will also find your own problems, and then the best way to solve your problem, to answer your problem is basically by solving the problem by yourself, right?
Great. So there is another question, the most upvoted one actually, which refers back to the beginning of your talk, I think. It's about how would you explain the difference between transfer learning and a pre-trained model?
Yeah, so pre-trained model is a kind of like the part of the transfer learning. Transfer learning is like the big terms, very big terms. It's like an industry revolution, right? So it's like very big term. Transfer and pre-trained model like a steam machine or this something like this, right? So it's part of this pre-trained model, and it's super important. It's like the cornerstone of the cornerstone of the transfer learning, and that's kind of the relationship, right? So because there's you cannot just just isolate these two terms. They are kind of like strongly bonded together. Right?
Okay, I think there is a related question somehow, if I'm not mistaken. What are your thoughts on AI as a service? So consuming AI without any fine-tuning, does it have a future?
What is your thought, Isaiah? So consuming AI without fine-tuning, does it have a future? Yes, but again, it's basically what Hugging Face did, right? So what Hugging Face is doing, Hugging Face already provides you a kind of like a AI model as a marketplace, or pre-trained model as a marketplace where people can use that. But in the end, this kind of things usually you can provide that, and I mean people will accept it, and people will gladly accept it and use it, right? You will have your market, but then people. Human never satisfied. Right? Human are never satisfied. Human are very greedy, right? If you give something for free for them, like a pre-trained model, you offer them as a service. They use your service and they will ask for performance, right? They ask for performance in terms of the scalability and also in terms of the accuracy of precision, right? And then on the one day you will have to go to fine tune, right? Because there will be no generic model that can solve every problem, right? And just like let's say there is a mighty God that kind of like understand every piece of knowledge in human history, right? And if you introduce a new thing, right? So just like for example NFT, right? So this kind of non-fundable tokens, this kind of things, right? So if you introduce this NFT to those almighty God, they still have to learn, right? What is NFT? What is this new knowledge, right? They still have to fine-tune their existing knowledge base into this specific domain. In the end, don't innovate for innovate, right? Innovate for solving problems, and people love those solutions can really solve their problems. Not those solutions are just for innovating, right?
Perfect. I think there is a question the other way around. So what are scenarios in which it's not appropriate to use pre-trained models with fine-tuning, for example?
I think the pre-trained model is usually like a super big, right? So usually a super big and super complicated, where usually you need some GPU. Even in the inference time, right? Even during the inference time, right? So that's kind of like a set of blocker for a lot of people. If you have very limited resources, let's say you're basically doing something on the edge device where you only have a Raspberry Pi, where the CPU is at 300 megabytes or 800 megabytes or something, right? So you don't have many computational resources there, right? So you have two ways to compute this on edge device. Either you upgrade it on the hardware perspective. So let's say you incorporate the latest ARM V8 devices, V8 chip into your edge device. So that could elevate part of the computational resources problem. Or you say, I'm not doing any competition on the edge side. I just send all the things to the server and let server handle. So that's also kind of as a service, software as service mindset. But let's say in some scenario, you still want to solve it locally, right, on your edge device, where your edge device is not so powerful. So in this case, usually you don't want to use very highly pre-trained models, because those models are usually just too big. One model could just like a 200 megabytes where it cannot be even fit into memory, right? So that's kind of the kind of the blocker of using pre-trained model. And the other thing is, let's say if you have a new problem that is not very well formulated, unlike say text classification, unlike natural language processing, and so on, and there is no such not so many data that can that you can leverage, right? So this is basically where the pre-trained model cannot be used very well, because you cannot really transfer the knowledge to this particular domain, because in there you don't have so many data that to build the model, right? So that's kind of the two restrictions for the pre-trained model. But in general, I would say there's still just like there are many applications where you can use pre-trained model and where you can apply this idea of transfer learning and fine-tuning in your domain. Yeah.
Cool. I think they really complement the picture of pre-trained models. So finally, there's one last question, more technically. Does Gina 2.0 still allow to customize microservices, for example, even though these components are hidden for developers?
Yes, of course. Yeah. So we actually so our microservice architecture is super powerful, so one can even say that we kind of like build our own Kubernetes. So that's so you can basically, if you use our microservice architecture, you can forget about Kubernetes. But in the meanwhile, we are also like after 2.0, we are also building the Kubernetes support and so on, right? So that's kind of so basically you don't have to sacrifice the usability or the flexibility when exchange for usability. But that of course requires a lot of experience, a lot of expertise in this domain in order to keep these two things balanced. But I think we managed to balance them very well in 2.0. And then right now we are working on the 3.0, where basically bring the scalability to the next level. And this you will see probably at the end of this year. Yeah.
Okay, so roughly speaking, one can use your API, your product, without even customizing it, just like leveraging your usability you mentioned. And also, if you are more familiar, you could customize it and make use of your own ideas and components.
Yeah.
Great. Cool. Okay, I think that's it from Slido. If there's anything left, please unmute yourself if you have any questions. I'll wait for 1 minute or so. Okay, seems like there are no questions in the meantime. So yeah, one last remark. There is one upcoming event we are planning to have on November 1st. So there is a roundtable discussion with 3 interns actually from Microsoft, Amazon, and Google. So yeah, stay tuned and feel free to join. I think it will be really exciting to hear some war stories and some experiences they got. So yeah, don't miss your chance to join this event. It's actually yeah, pretty near. And to not forget about any further event, please feel free to join our socials. Especially we are active on LinkedIn, Twitter, and if you wish, join our Slack community to keep updated. And as Han mentioned, also join the Slack community of Gina to keep posted about topics in their company. Cool. Then I think that's it from my side. Yang-Da, if you have anything more to mention, feel free. Otherwise, that's it for today, I think.
Yeah, thank you all for coming. I've also just posted our DSC website and some links here, so feel free to follow us and make sure to subscribe to our newsletter. Yeah, thanks you all for joining. Thanks.
Cool.
Dr. Xiao for coming, and it's really insightful speech. Thank you so much.